This is a NEET 2019 Versa question in two-dimensional motion. Let us try to understand what the problem is first, right? Two bullets are fired horizontally and simultaneously towards each other from the rooftops of two buildings 100 meters apart at the same height of 200 meters with the same velocity of 25 meters per second. It's a very long sentence. Let's try to understand what's the meaning of that, right? There are two buildings. This is building 1. This is building 2. Each of these buildings are having a height of 200 meters, separated by a distance of 100 meters. Two bullets are fired horizontally. This is bullet 1, fired this way towards each other. This is bullet 2, fired in the other way. Both of them are fired with same velocity, 25 meters per second, 25 meters per second. Then the question is, when and where these two bullets collides with each other, assuming gravity is 10 meters per second squared. The first thing that you need to understand is, as these bullets are under the influence of the gravity, they cannot continue moving along a straight line, as the gravitational force also starts pulling them down. We have given some velocity along x-axis. It will further generate, after starting moving, some velocity along y direction, like b equal to u plus at. U is 0 in this direction, but it will acquire some velocity using a formula u plus at. U is 0 and g into t. How much is that v, though not that much relevant in this problem, but they do acquire some velocity as the time progresses. So as there is velocity in both the directions, it's going to be a two-dimensional motion and it will move this way like a partial parabol. That's the bullet 1. The bullet 2 also, under the same way, moves this way. They will meet somewhere here in the journey, right? So where do they meet? When do they meet? That's the question that is being asked. But when they are asking when do they meet, what after what time? Where do they meet means at what height? That's the question. At what height is the question that they are asking. And the options given, though I had taken only one option because of the printing reasons, there is only data given in terms of the heights, not in horizontal distance. So let's assume that this first bullet will travel some distance x1, second bullet will travel some other distance x2 before they meet at a particular point. So what we can say, the total horizontal distance x1 plus x2 is given as 100. How can I get this horizontal distance? This horizontal distance is using the formula something like s equal to ut plus half at square. This is x1, u is 25, t I don't know, plus half. Acceleration is 0 in horizontal direction because it is projected horizontally with a constant velocity. There is no acceleration in that. So x1 becomes 25t. x2 also the same because it started with the same velocity. They will meet after the same time. So x1 is 25t. x2 is also 25t. Together is 100. So 25 and 25, 50t is 100. So t is going to be 100 by 50. That equal to 2 seconds. So we got one information that they are going to meet after 2 seconds. That's the first information. And then we have to calculate at what height they meet, right? First, let us find out how much vertical distance that they fall, this value before they meet. They fall a vertical distance y. Both of them fall a vertical distance y. Then only they can meet. They are not going to fall different distances because both of them have initially no velocity in the y direction. Both of them under the influence of same gravity, right? So their vertical distance fall of the height of the bullet before they meet. Using a formula s equal to ut plus half at square. h is equal to 0 into t. Be careful. This 0 is not about this velocity, but this is about vertical displacement. It has no initial vertical velocity. Half a is plus z in the vertical direction. T square means because we already calculated t as 2. So h is half, g is 10, 2 square is 4. So this value is 20 meters. And be mindful that you are calculating the height from the top 20 meters. From the bottom, how much is that height? Is that from the ground? How much is that? This is the ground. Altogether 200 meters. But that has already fallen 20. So this remaining distance will be 200 minus 20, 180 meters. So that implies what we can say. From ground, they may height of 180 meters after 2 seconds. That's how we have to solve the problem. Though the problem looks like lengthy, it's a simple problem and it's easy to understand, can be done basing on very basic concepts itself, right? Okay, right. Thank you for watching. You can solve this problem in other way too using a relative velocity, but I feel this is easy to understand when compared with that, right? Yeah. I can quickly tell you what is that alternatives anyway, just for the sake of a discussion. Because these two velocities are in opposite direction, we can write v relative as v minus of minus v because one is opposite to other. So it becomes 2v, that is 2 into 25. So that is 50 meter per second. That's relative velocity. We can write relative velocity as displacement by time, velocity like definition itself, velocity definition itself. Displacement is separation 100 by time. So velocity is 50, 100 by time. Time will be 100 by 50, that is equal to 2 seconds. The other part of the problem, height of the problem is just similar to this. Whatever we have done, we will get to the same answer. So only to find the time, we have an alternate method. Alternate to find time after which they are going to meet. You can use any of these things, whatever is comfortable for you. That's it. Thank you for watching.